Why is desalination so energy intensive? Imagine turning seawater into fresh drinking water. Sounds simple, right? But behind the scenes, it takes a lot of power to make that happen. That's because removing salt and other minerals from water is not easy. Seawater contains about 3.5% salt by weight, which is a huge amount to separate. To do this, desalination systems have to work against the natural pressure that keeps salt dissolved in water. There are two main ways to do this. The first uses heat. These are called thermal processes. They heat seawater until it turns into vapor, then cool the vapor back into water, leaving the salt behind. This process needs a lot of heat energy, often between 80 and 120 kilowatt hours of thermal energy for every cubic meter of water. It also uses electricity to run pumps and control systems. Heating large amounts of water repeatedly is very energy demanding because it's thermodynamically intensive. The second method is membrane-based, known as reverse osmosis. It pushes seawater through special semi-permeable membranes that only let water molecules pass. To do this, very high pressure, often over 60 bar, is needed to overcome the osmotic pressure caused by the salt. This process uses electrical energy, typically 3 to 5 kilowatt hours per cubic meter of water. While this is less energy than thermal methods, it is still much more than what is needed for treating freshwater from local sources, which can use less than 0.2 kilowatt hours per cubic meter. The salinity of the source water also affects energy use. Brackish water, which has less salt, needs less power to desalinate. Advances in membrane technology and energy recovery devices have helped cut down on energy needs. These devices capture and reuse energy from the process, making plants more efficient. Still, the physical and chemical nature of salt water makes desalination inherently energy-hungry. Think about it this way. If all household water came from desalination, it could boost electricity use by about 10 to 15%, similar to running a refrigerator constantly. Some modern plants now use renewable energy sources like solar or wind and energy recovery systems to cut costs and reduce carbon emissions. In the end, desalination is energy-intensive because it has to fight against the natural forces holding salt in water. Whether by heating water to vapor or applying high pressure to push water through membranes, these physical barriers demand a lot of power. Despite improvements, the process still costs more energy than sourcing water locally or treating fresh water. That's why desalination remains a powerful but energy-hungry way to get clean water from the sea.